Let's see what this change looks like in code. Here is our country class. It was there all along, but hasn't been used until now. We're now going to add the country references to our object model. Each country has a collection of states. And each state has exactly one country, but we can't make it required just yet because the existing states don't have a country yet. So we'll make the country ID property nullable for now and come back to that in a minute. We're also going to rename the address class's zip code property to postal code. Now let's update the seed values to add the postal code label and state label fields for the countries. Then we'll update the states to specify their country and add the Canadian provinces and territories. Finally, let's create a migration to capture these changes. From the Package Manager console, we'll add a migration. I'll call mine Added Country to State. I like to specify the project where the migrations live and the startup project that contains the configuration, just to be sure the values are what I want. And we'll apply this migration to the database. And that's step 1. Our states all have countries now, so we should be able to change the country ID property to be required and generate a second migration, which I'll call Require Country on State. I've already added other country-related items such as the country DTO, its mapper, the country service, and country controller, so we should be all set. Now let's run our tests and see what happens. As expected, there are a few broken tests. The fact that the state class now requires a country means that several of our tests that involve states need to be updated. Let's fix one of the tests now. This state repository test fails because we can't save a state without specifying a country. Fortunately, all we need to do is fill in a valid country ID, and this test should pass again. These are the kinds of changes we deal with on an almost daily basis. We're constantly adapting to new requirements, adding new objects, throwing out old obsolete ones, and generally trying to keep up with the business. Tests help us to ensure that we don't break existing functionality when we make these changes, and allow us to refactor fearlessly, knowing that our projects continue to work despite these changes. But how can we trust tests when they're so resistant to change and so easy to break? Many developers simply give up on the idea of testing, throw up their hands, and walk away, and that's the last thing we want. We want to keep the tests up to date at all times. The test for adding a range of states is still failing because it was expecting a specific ID for the last state after adding 2 new ones. That number used to be 58, but with the addition of the Canadian provinces, the new number should be 71. That takes care of the state repository tests, but there are still a few tests that are hung up on that renaming of the zip code property. Global Search and Replace should fix those up. And now all the tests are passing again. In order to get everything green again, I've had to update a few different tests, and even though the changes were simple, you can see how a small change can have far-reaching effects. Let's take a look at some of the factors that contributed to the scope of this rework. First, there are a lot of magic strings and numbers scattered throughout the tests. For instance, the expected record counts and property values. These hard-coded values are generally considered poor practice in your production code, and they shouldn't be accepted in your tests either. The only reason they're working here is because of the main problem. The tests are doing everything themselves. My order repository tests are creating their own instances of the address class, which isn't really core to what the test is about. Let's take a moment to talk about the law of Demeter. I'm not going to get super strict about the definition here, but in general, when we talk about the law of Demeter, what we're talking about is the principle of least knowledge. That is to say that one part of the system shouldn't know too much about the internals of another part of the system. It's not really any of the order's business that the customer has an address. The order just needs a customer. Anything beyond that is the customer's responsibility, not the order's. This same principle applies to our test contexts. This test should be focused on what it's doing with the orders, not on the minutiae of every object that goes into creating an order. The vast majority of the code in this test isn't directly related to what we're testing, and it's not clear to a reader which values are actually important and which are there just to satisfy a requirement. When a future developer needs to maintain this test, how can they tell which values are expected to have some kind of effect on the test's outcome? Does it matter that all of these addresses are in the same state? Code should be self-documenting, and right now, this test is anything but. These magic strings also pose another problem. We've only proven that the code works for this one specific set of values. If it works for these values, it should work for others, but we haven't really proven that, have we? Taken all together, these problems add up to a rigid and fragile test context that doesn't clearly communicate its intent. In this module, we looked at a sample API project, its related test suite, and saw the repercussions of a fairly simple business requirements change. We observed the mess that it made of the existing tests, even the ones that had nothing to do with addresses. Then we fixed up those tests to demonstrate just how disruptive a small change can be to your workflow. And finally, we highlighted some of the shortcomings of the current test suite's approach to generating and validating values. In the next module, we'll look at factoring out this test context generation into an object mother so that it can be shared by multiple tests.